Good afternoon, everybody. Thank you for coming to this Schneider Electric press conference. We appreciate you taking the time to spend an hour with us. I'm sure some of you have come here to learn about Industry 4.0. It's one of the main themes at the show here, and I will definitely be spending some time on this subject. In particular, I'll be emphasizing Schneider Electric's commitment to open industry standards, to collaborating with our suppliers, with our competitors, with our customers, to develop and deploy open de facto standards to enable the Industry 4.0 promise to be realized. My name is John Conway. I've been in automation for, I'm afraid to say, coming on 30 years now. It's actually my birthday today. I'm 54 years old today. And this is what I get to do for my birthday. So I must have done something wrong in a previous life. But actually, it's a pleasure to be here. I'm going to give a very quick introduction to Schneider Electric, talk an introduction to the industry business, and then I'll get into the subject of Invensys, a few words about the Invensys integration, and then I'll get on to the main subject, which is Industry 4.0, IoT, and what Schneider is doing. So Schneider Electric is a large multinational company, $25 billion in revenues, 4 main businesses. This afternoon, I'm representing the industry business unit. Philip, my colleague, is representing the infrastructure business unit. And between us, we're a little over half of Schneider Electric's business. When I say industry, I mean automation and control. That's our business. We are a global player in the automation business. We have revenues of 5.6 billion euros. And we essentially have 1/3 of our business is systems and solutions, 2/3 is products. It's a very nice, it's about the right mix, I believe, for our business. The system solutions gives you customer intimacy and lets you feedback what you need to feedback into your best-in-class products to make good products. We're in multiple segments, everything from heavy oil and gas process, continuous process control, through to discrete manufacturing, machine builders, packaging, food and beverage industry, etc. Most customers, pretty much all customers, have some Schneider Electric products somewhere in their facility. We may or may not know about that, because a lot of our products actually flow through a very widespread distribution network. But we're a well-known brand within the automation business. Next slide, please. This slide here, very complicated. I will not spend too much time on this. It essentially has 2 axes, a horizontal axis. We have products right from the level 1 field device level, instrumentation, push buttons, contactors. Level 2 at the control level, programmable logic controllers, etc. We have our systems, a combination of hardware and software that runs the systems. We have systems for our OEM machine builders. We have systems running refineries, the Foxborough DCS system. We have safety systems also controlling the safety in those refineries. And of course, with the Invensys acquisition, we acquired a very healthy leading software business, which is a critical element of our Industry 4.0 strategy as we move forward. And that brings me to the subject of Invensys. Essentially, traditionally, historically, Schneider Electric was more of a discrete manufacturing company. With the acquisition of Invensys, we are present in the continuous process control industries. We acquired the company just over a year ago now. We've had a very busy year doing a lot of work, a 50-person team carrying out the integration. 10,000 employees are fully integrated inside Schneider, inside the systems, Schneider Electric email, etc., etc. We have one unified management structure, combining Invensys and Schneider Electric employees, a unified management structure, and we actually have unified R&D teams, and we are starting to converge the roadmaps for our automation systems and products. We had quite aggressive cost synergy targets, which we are on track to meet. And now we are starting to see revenue synergies. And I'll just give you one example here of this is the Reliance Jamnagar refinery in India. I apologize for the pronunciation. I'm sure it's wrong. It's the largest refinery in the world, in fact. And Invensys was the supplier of the DCS and Triconic safety systems. And we leveraged the Invensys trusted advisor relationship to convince Reliance on the next phase of the refinery extension to use Schneider Electric low voltage and medium voltage equipment. So a very good example of the two companies coming together, automation and control. The trends, industry trends, the medium to long-term outlook for automation is very good. There's many things that are driving that. These are the main ones. Investments in infrastructure will continue in the future. In mature economies, we have a lot of aging control systems that have to be upgraded. Increasing regulations, whether that's the pharmaceutical or the food and beverage industry, whether that's the oil and gas industry, increasing regulations is a growth driver for the automation business. But more importantly, this one here, volatility. We're seeing volatility. It's not just things going up, it's things going up and down over short periods of time. And we're right in the middle of that right now with the oil price, which has declined 50% in the last 6 months. And the euro is going down and the dollar is going up. And it's actually a complex time right now in business. And it's a complex time for our customers, and they have to adapt their production to this volatile market. And I think that is probably one of the biggest use cases for the industrial Internet of Things, for Industry 4.0, is to allow manufacturers to be much more flexible in the way they produce, in what they produce, and allow them to respond very quickly to these changing volatile conditions. Next slide, please. Having said all that, we see the industrial Internet of Things as an evolution and not a revolution. And for two basic reasons. First, our customers hate revolution. They've invested hundreds of millions of euros in automation and control systems. They do not want to change them. They want us to help them evolve them. So by the nature of industry, very conservative, it's an evolution. It's also an evolution for us because we have been pushing this since the mid-90s. In the mid-90s, we started introducing Ethernet into our control systems. We started embedding web servers inside our control systems. We call this our transparent factory. At the time, we released the Modbus TCP standard as an open standard, so we allow anyone to implement Modbus TCP on Ethernet. And it still today is the most widely used protocol on Ethernet because it's very, very simple. So really, an evolution, not a revolution, but like a steamroller, it's moving forward slowly, but it will not stop. And the promise for industry is smart. We talk about smart connected products. I'll come back to that in a minute. Smart connected products we supply to our customers. They make smart machines, smart plants, and those smart plants operate in the context of a smart enterprise. So we no longer just optimize a plant floor, we optimize multiple plant floors and the supply chain that links them together. Okay. Cybersecurity, I won't spend too much time on this. I'm not an expert on cybersecurity. What I will say, it's one of the biggest questions that end users have with the whole Industry 4.0 industrial Internet of Things. They are very concerned about cybersecurity. We are seeing more and more cybersecurity attacks. So as suppliers, we have to reassure our end users and address this properly. You have to address it in your design process. It's not something you add on at the end. You must address it up front. And Schneider Electric, of course, is doing this. And we are supporting we are pushing very hard the development of the 62443 IEC standard for cybersecurity. We also have inside Schneider Electric, was part of, in fact, the Invensys acquisition, we acquired a small group of consultants providing cybersecurity consultancy services to end users who want advice on how to best implement the automation systems in a cyber-secure way. Next slide, please. Sorry. So this slide, two messages on this slide. I've already touched on this message, Internet of Things, a pioneer. I've mentioned we've been working on this since the mid-90s. But the message here is not to say this is Schneider, we're a leader. That's not the message. The message here is that Schneider Electric is committed to open industry standards, and we have been since the mid-90s, pushing very hard for the industry to develop and implement open standards, because that's the way that we can get on with our real business of providing value to customers. And one of the challenges of Industry 4.0 and industrial Internet of Things is there are still some standards that have to be developed. When a car body comes down a production line and shows up at the paint shop and says, "Paint me red, please," that exchange, "paint me red," we can hard code that today, that's not a problem. But if we want to develop a standard, an interoperable standard, that exchange of "paint me red, please" has to be standardized. And there's things like that are still missing today. And again, Schneider Electric, we are fully behind, and we will collaborate with our customers, with our competitors, to put in place those standards. So stay on that slide again, please, Marie. Go back. It's okay. Now, the good news is we're not waiting for standards to arrive. There's lots of things we are doing in this area today. Now, when I talk about the industrial Internet of Things, there's the notion of Internet, there's the notion of the things. And when we talk about things, we talk about smart connected products. Essentially, electronics, embedded electronics, getting cheaper, more powerful. It's becoming very simple and straightforward to embed electronics in field devices. And essentially, the intelligence is being distributed more and more into these smart connected products, okay? And that's a key area of development for our best-in-class product business. We call it innovation for simplicity. We innovate to make things easier for our customers. Here are a few examples that you can see on our stand if you have time to visit us. Dynamic QR codes, very simple idea. When for example, a variable speed drive stops on a production facility, quite often you'll get some obscure error code on the screen and you'll have to go find the documentation to figure out what to do. With this dynamic QR code, the operator shows up, he flashes the code with his smartphone, with his tablet, and he can be connected directly to either to an expert in our customer care center, or he can go straight to the page in the documentation that tells him how to recover from the problem. So a very simple example of these modern technologies that allow us to reduce, in this case, reduce downtime of a process drive. Mobile apps using smartphones and tablets, very useful in commissioning to actually quickly connect to devices, see the status of the device, perhaps change something on the fly. Very good for operations, very, very practical, simple things. Wireless and less wire, that's a complex subject, wireless, but in simple terms, when you install an automation system, the biggest cost is the installation cost, running wires, running cable tray. You will never eliminate that completely, but you can reduce it, and you can make things more simple. And that's a big focus for our best-in-class product business. And finally, embedded intelligence. Again, the example here is, I use the example of our drives. We are embedding inside the drive. For example, we can embed the pump curve inside the drive. And what this means is we can monitor where the drive is running on the pump curve. And if we detect that the drive is running most of the time on the wrong part of the pump curve, we can correct that. And that's very important. In simple terms, if you run a pump in the wrong part of the pump curve, you wear the pump out very quickly and you consume a lot of energy. It's not very efficient. So these are very simple things, embedding intelligence inside the products in the field to really bring some sort of tangible benefit to an end user. Next slide, please. And we're very proud. You can see this on our stand again, the M580 Programmable Automation Controller. We received the Control Engineering Award, Controller of the Year Award for 2015. What we've done with this controller, it's the culmination of our 15 years of work on Ethernet. We actually have Ethernet embedded in the backplane of the controller. So I don't know if you're familiar with controllers. You have a backplane, you plug input-output cards into the backplane, you plug intelligent modules. That backplane is Ethernet, okay? What that means is our customers, our partners, they can actually develop their own modules and plug them into that Ethernet backplane. Because it's Ethernet, it's an industry standard that everyone understands. And while the actual requirements of Industry 4.0 are not fully clear today, we're Industry 4.0 ready, and we can develop very simply, our partners can develop modules to integrate inside an Industry 4.0 architecture. Next slide, please. I won't spend much time on this slide. I've kind of covered most of these points. You'll get a copy of the deck afterwards. It's just a few examples of the different things we're doing inside a drive. And at the end of the day, it's about improving production efficiency. Next slide. And please, as I said, go to our stand and you can see our Wonderware demo. We're doing a demo on our Smart Glance software, which is essentially software running on mobile devices, giving you real-time access to information from controllers, from your MES systems, from whatever, okay? But that's what we talk about smart connected products. Now, in terms of what are we doing in the cloud, we're doing several things, but again, here's an example I quite like because it's something that is not the classical big data analytics. It's something actually quite different, but again, very pragmatic and extremely useful for customers. It's what we call engineering in the cloud. If some of you are familiar with automation systems, when you develop an automation system, you end up in a room like this with all the hardware at the back there making lots of noise, and you maybe have 10 engineers sitting down, programming and configuring for maybe 6 months, 9 months. Away from their homes, very expensive, not very efficient. Now Schneider Electric, we can actually put their system in the cloud inside one of our data centers, and they can work on the system remotely from different countries. So now different engineers from different countries can work on the same system. They can do more thorough and more complete testing. And as well as reducing the cost of configuring the system, the real benefit is when the system finally ships to site, it's of a higher quality level and the commissioning is much quicker. So we actually shorten the commissioning time of a large, complex automation system by using the cloud. Next slide, please. This is a more complex example of this is an acquisition of a company we made a couple of years ago called Solvit, an Australian company. Remember artificial intelligence? We had a lot of talk about that probably 15 years ago. Actually, artificial intelligence is mature today. And here's an example of artificial intelligence, which is just another form of advanced analytics. What these guys do is we provide decision support systems for complex manufacturing operations. This is an example of a mine. And if you think of a mine, what is a mining operation? It's maybe 10 different mines extracting iron ore. It's a complex network of a rail system going to a port, and it's boats coming in to the port to be loaded up with iron ore for shipment to customers, okay? That supply chain is actually, it's actually managed as one supply chain, and it's quite a complex thing to manage. And what happens if a train breaks down? What does the operator do when a train breaks down? Which order does he cancel? Can you get the iron ore from another mine? What is the impact on throughput? What is the impact on profitability? It's a very complex problem. So what we do is we model that supply chain. We do a detailed model. And then we solve, when the train breaks down, the operator can say, train's broken down, what do I do? The model runs, and 15 minutes later tells him, you should do this. And this is why, and then explains why he should do that. So it's not a black box. It says, cancel this order, cancel that order. That will optimize the profitability of your operation. And here's why. Now that actually, what's unique about that is you cannot do that with conventional linear programming techniques because the model is too complex and would take 50 hours to solve. Using artificial techniques, it takes 15 minutes. And that's the big breakthrough. And that's a typical application that I think is, I would call that the industrial Internet of Things, Industry 4.0. So I've come to the end of my presentation. We'll have questions at the end, so you can ask questions. But I would encourage you to come visit us on our stand in Hall 11, booth C50. You can see the modern Bodycon 580 controller with the Ethernet backplane. You can see the Altifar process drives that I spoke about with the dynamic QR codes, the embedded intelligence. And you can also see the Invensys systems that are now fully Schneider Electric, the FoxPro DCS, the Triconics safety, and of course Wonderware and the Wonderware Smart Glance demo that I spoke about earlier. Okay? I think we hold the questions to the end, right?
Thank you very much, John.